This conference will now be recorded.
So here see, runoff means whatever the excess rainfall occurs, and once the capacity of the soil becomes uh, over, then runoff starts, right? And we have seen what is direct runoff, what is base flow, right? Then here some of the diagrams are given. Here the it is also given. This is a open channel. It is our nature, right? If you will observe it properly, if you will watch, then you will find that here our channel. So what happens when rainfall occurs? When rainfall occurs, most of the water goes into this filled with water, right? Then some of the part of water goes into the very in depth, right? And this is called as base flow, and this base flow meets to the uh, we can say water table, and simultaneously it comes into the river after say 6 or 8 months or 1 year, and it meets to and it continuously comes. So what happens when these waters come from both sides? So you will see that this river flowing here, it always flow continuously, it flows for the whole year, right? And when rainfall occurs, water flows over the surface. So this is called as what? This is direct runoff, which is directly flowing over the surface of the earth, right? And subsurface flow means this one, or base flow we can say. So you will see that the all water which is coming here when rainfall is occurring, the rainfall is occurring here, here, everywhere at every part. So what is happening? From all over the earth, the water is coming where? Water is coming into the river. From here also water is coming into the river, and this water, so whole water comes and it joins to the river. So at this point uh, we can say one gate is prepared, or we can say some arrangements are provided so that we can measure the discharge, right? So here we can measure the velocity, here we can measure the what is c. If we are able to measure the if we are able to measure the area, this area, right? This is what? This is trapezoidal. Now the knowledge of fluid mechanics will come here. How? If you know that this is trapezoidal channel, right? And if you know the this breadth, say this is b, this is small a, this is say what is this angle we can say, right? So if you know everything, you can find out the area. Now once area is clear to you, how you will find? Then you know that according to the in the fluid mechanics, discharge is equal to what? Velocity into area, right? So here the velocity is measured. What is the velocity and what is this area? Once you know this area and you know the velocity, you can find out the discharge, that is q in meter cube per second, right? So I think it is clear to you. So when runoff means whatever the water is coming over or flowing over the surface of the earth after the rainfall. It is collected at river from all points, or it is collected at the open channel. River or open channel means what? Open channel is nothing but our river. And here we can measure how much quantity of water is passing in a 1 second. See, this is per second, and meter cube means suppose that maybe 1 meter cube per second, right? So you know that discharge. So we can measure the discharge, and if we know the discharge, then we can calculate how much time will be required to pass this quantity of water. So we can calculate the how much quantity of water is collected. For example, if this 1 meter cube per second is continuously flowing for 1 hour, 1 hour means 1 and 60 minutes multiplied by 60 seconds, right? So here it is second, here it is second. Second will cancel. Then you will find that in 1 hour, how much quantity of water, or how much quantity of water or volume of water, how much quantity or volume, because it is in meter cube. So how much quantity of water is passing at this section when, for example, when rainfall occurs, say 10 mm. And where the rainfall will be, we will get rainfall because in the whole area we have some rain gauge stations, right? So suppose there is a rain gauge station installed here. So whatever the rainfall occurred, so it will be collected here. So through this rainfall, suppose this is 100 mm rainfall occurred. So after 100 mm rainfall in this whole area, this whole area maybe say 100 or 200 or 500 kilometer square, right? So for this 500 kilometer square area, if this much amount of rainfall occurred, so after that rainfall, what was the runoff, right? We can say the runoff for this particular rainfall occurred. So this is for one event. Suppose on the next day again, suppose 100 mm rainfall occurs, then again we will check what is the runoff at this particular point. Now the second question is how and who will calculate, who will measure this discharge, or who will measure the velocity at this particular site, right? So there are the different methods. There are the how we can measure the velocity, how we can measure the discharge, right? And at this point when the discharge is collected, like what I said, this queue is clear to all of you. See, this queue is for only particular 100 mm rainfall. When suppose this is occurred for 1st of December in 2020. So for at 1st of December, 100 mm rainfall occurred. 100 mm rainfall occurred. Then due to this 100 mm rainfall, how much value of Q is there, right? Then again next day, suppose, or so we can say suppose after 2 hours again rainfall occurs. So again the rainfall will be measured. Suppose this is 100, and then again we will measure the Q. Likewise, we will measure all rainfall. We will measure all runoff, right? And based on this data, we prepare a hydrograph. Is this okay? Now up to this, what I discussed is clear to you?
Yes, doctor.
No. So here, so surface runoff means after the rainfall, whatever the quantity of water flows over the surface of the earth is called as the surface runoff. That may be in the stream flow, that may be the runoff over the channel, that may be on the surface of the earth. What is the importance it is saying? Stream flow is one of the most important topics in engineering hydrology because it directly relates to the supply and flood control. Yes. See, the knowledge of this one is very important because in case if we will have this data, then we can predict the flood, right? We can predict the flood. Maybe suppose after if continuously rainfall is occurring, then there may be the chances of flood. How we will say that the chances of flood is there? Because we will have this data, this q data. We will have the rainfall data, we will have the velocity, we have the discharge. So based on that we can predict the flood. Now, reservoir design, obviously when we know we have this type of data, like for every year this much quantity of water is collected at this particular site. Then what we will do, we will make a one dam. Suppose here we will make one dam, we will make one dam, right? There may be that small dam, we can construct a small dam here, and we can store this water. But how we will uh, come to know that the dam should be very large or small? It will be depend on the data which is collected from last 30 or 50 years. Then based on that we can design, the structure or reservoir. Then irrigation, drainage. See, through this water, suppose there is some we can say some dead uh, tree are there. Suppose there may be the trees, or at the downstream side there may be some trees, right? At the downstream side, suppose here somewhere, some, if this water will come somewhere here, if there are some trees, so water can be supplied. So this water will the supply of water will be decided based on the water collected in the stream, right? Then we will check what is the water quality, and likewise we can plan the uh, various projects based on this data related to the hydrology. I hope this is clear. Now, here is the stream flow measurement, right? You might have seen the river. When river flows, see the water is coming here, and here this is what, this is the channel, right? This is the channel and water is coming here. So how we measure this flow? What I told you in the previous slide, when water is coming into the channel, then we have to measure the velocity, we have to measure the discharge. Then how we will measure? Suppose this velocity is there, how we will measure the flow, this velocity? How we will measure the velocity of water which is passing over this channel? Then there are some methods to measure the discharge or to measure the velocity also. So here, the first, here it is given as the measurement of discharge. Measurement of discharge means how we measure the q. And what is, you know that what is q? Q is the velocity and area. Means if we know the velocity through which water is flowing, and if we know this area, this is, I said this is total area A, and if you will see, it is a combination of almost number of areas, right? See here, it will be A1 plus A2 plus A3 plus, likewise. If we know the total area, right, and if we know the average velocity, we can say, so we can find out the discharge which is passing through this river. This is our river and this is the area. Is this okay? Mira, Zayed, Salim Saif, Nadia, yeah, okay. Now, so here, now I want to show you something in more detail. See here, now you observe this, just you watch this. See here, if you will see that the river is like, you see one box, this one box is there, right? I say this is area 1. How I will know this area? See, if I know the breadth of this, if I will take it outside here, it is like, see, actual area, this, there is something ground, right? So we are considering only that this is the area, right? But actual area is only this one. See, actual area is only this one, right? But now we are considering that this is total square. So if we know that this breadth, if we know this breadth, and if we know this depth, this is d, so we can find that breadth into depth will be nothing but area, right? So likewise there are the number of breadth and depths. So here say, I say this is b1, this is say b2, this is say b3, this is b4, likewise whatever, suppose there may be 10 or 20, whatever is this. So once we know, suppose a1 to up to, suppose there is 20 areas, so we know that there are the total areas are 20. So I will, what I will do, a1 plus a2 plus a3, likewise I will go up to a20, right? Once I will add this, I will know that this is my total area A. Now next question is how I will calculate the velocity. So there are some methods we can calculate the velocity through that method, and once we know this velocity, we know the total area, then we can get the discharge that is in per second or in per hour or per minute or per day, we can calculate. So here, see here, in each subsection, we know area, depth multiplied by width, and discharge is what, area into velocity. Then we can get the q value. So likewise, for every river, if we know the velocity and we know the area, we can calculate the discharge over through that river. So here, so first is, if we have to measure the discharge, then we must know what is the area. Next, what is the velocity? We must know how to measure the velocity. Once these two terms will be there, then we can calculate the discharge, that will be in meter cube per second. I hope this is clear to you. Now, so we will see different methods will be available here. So first, they are talking about the various devices which are used to measure the velocity. Like how we will measure the velocity, right? Velocity. So there are some methods. So first is float, second is pitot tube, and third one is current meter. So these are what? These are the methods through which we can calculate the velocity. So floats means suitable for a straight channel, means what? We will see it. Now here, just wait. Okay, now, so we are talking about float method. So float method is what? See, simply, if we know this is the channel and water is flowing through this channel, right? So here you will observe that, just if you will watch it, if you will watch it properly, then you will find that, see, if you will watch it, you will find that from this point to this point, they have fixed some threads, and they have measured what is this distance, right? So they know that this distance is say 50 foot, right? So 50 foot means what? This is the length, right? And what they are doing actually, there may be what they will do, if some plastic ball is there, that plastic ball will be left from here, exactly from this point, and it will float. And once it will reach at this point, so what they will do, when they will start from here to here, they will note down the time. Suppose the time when it started was 0, and when this plastic ball reached to the second person here, that then the time was, say, 10 seconds, right? 10 seconds. 10 seconds time noted. So if we will, what we will do to finding out the t, so t will be what? T2 minus t1, t2 minus t1, this is say t1. So 2 minus, sorry, this 10 minus 0 means what? 10. So time is what? Time is 10 second. So this t time means 10 second is taken to travel the plastic ball from 0 to 50 foot, right? So this 50 foot is what? Length, and this t is what? Time. And we know that the formula for finding out the velocity is what? Distance upon distance upon distance upon time. This is what? This is time. So distance upon time, we can calculate the velocity. For example, what I said, this 50 foot is traveled in 10 seconds, right? It means what? 0 will be cancelled, means 5 foot per second, right? If I say this 50 meter is traveled in 10 seconds, so what will be that one? 50 divided by 50 divided by 10, this 0 will be cancelled, means what? This travel is 5 meter per second. So this is the method through which we can calculate the velocity. We can calculate the velocity, and this method is called as the float method. Is this okay? Is it okay? This float method is very simple. Like, you can also calculate the velocity if you go anywhere in the Oman and you know the distance between the 2 points. Just one person will left some plastic ball, and he will note down the time, and when that ball will reach to the target, again he will note down immediately what is the time taken. Then once you know the time, you know the distance, you can calculate the velocity of the river, right? This is the float method. Next method is the pitot tube method. So this method is suitable only for the clean water. Pitot tube method means what? See here, we have seen the pitot tube, I think, in the fluid mechanics. So pitot tube is, see, this is, say, suppose river, and here it is filled with water. This is filled with water. So pitot tube is a device. It looks like this. Here it is something like it will given something. Then here some small hole will be there. Just you assume this like this. Actually, I don't have this. So here what will happen when water will go? See, water is flowing in the river. What we do? This pitot tube is inserted into water. Water goes into this uh, pitot tube. It reaches up to certain point. This height is noted down, right? This height is noted down, and then the formula is given for the velocity. Through that we can calculate the velocity through pitot tube. Like this is some stagnant, this this is nothing but the kinetic energy is converted into this potential energy, and then the velocity is measured. So this is one of the method, and this is suitable for clean water. Next is the current meter. Current meter is again it is based on some cups and propellers. I will show you. Just wait for 1 minute. There is a Adan is there. Okay. Now another device is this is the current meter. Current meter is the device which is used to measure the velocity. How, what is the velocity? So here just you can observe that. See here. This is one of the diagram of the current meter. If you will see this, this is the current meter, right? So what happens when water flows? The water flows. So here there is some wings, we can say propellers are there, right? So this water, what happens? This water rotates that propeller here. See some is, these are the, here you can see this propeller. This is called as propeller, right? When water flows, now again come to this diagram. When water flows, see this water comes, so it rotates continuously, right? It rotates continuously, and the count, the number is counted here, right? Then there is some arrangement through which, and through which, see this number is counted, say that is denoted by how many times this propeller is rotated. For example, this is rotated for 100 times, right? For 100 times, how much time was required, then again that time is noted in the seconds, right? Once they know the time, once they know the number of this revolution, then they have developed one formula. Through that formula we can measure the velocity. So here we will see that what are those formula. So this current meter is clear to you? Current meter is clear? This is actually this current meter. Here somewhere propeller will be used. So here this propeller will be somewhere here, and when water flows, either it is flowing from here or it is flowing from here, they will rotate, and the rotation is noted, and the time required to that rotation is also noted. And this formula is developed. Once we put this number n value and s the time value, we can measure the velocity. So this is the current meter which is used for measuring the velocity. So in general, all these instruments are installed at various we can say irrigation projects or dams. At sometimes it is now, we can say, some old technology. Here some updated technology has come through which they measure this all velocity and everything. So this floats method is clear, then current is clear, pitot tube is clear. Here mean flow velocity estimation. Mean means what? Mean means the average, we can say, right? Average velocity. So according to scientists, if you are according to, we can say, engineers, there is the concept that, what, suppose this is our river, for example, water is flowing. This is the top surface. This is the surface, top surface where the water, this is the water level, right? And this is the bottom level. So according to scientists, what they say that at the bottom, generally at the bottom, velocity is almost considered as a zero, and at top it is considered as the maximum. It is considered as maximum. So velocity is considered as maximum at top, and it is zero at bottom, right? So here they had said that if the depth is less than 0.6 meter, then this v bar means average velocity is taken as 0.6 times the water depth from the water surface. But if the depth is, if the depth means what? Depth of river, this depth. If this depth is less than 0.6 meter, then what they are saying, then the average velocity is taken as 0.6 times of the depth. That will be the average velocity. This is clear? This point is clear to you? This point is clear? Now, if the depth of the river is between 0.6 to 2 meter, means if it is more, this is, I say this is suppose 0.6 meter, right? Now, if it is more, like it is between 0.6 to 0.6 to 2 meter, then what they do? Then they take the average. Then they take what? That velocity at 0.2 times of the depth plus 0.2 times or 0.8 times of the depth and divided by 2. Is this point is clear? For example, this depth is say 1 meter. So this 1 meter is what? 1 meter is greater than 0.6 meter, and it is less than 2 meter, right? So we will take this 1 meter, we will put here in this formula. In this formula, I will clear it. Then again, it will be like, it will be okay to understand. So what I will do, this 0.2 into 1 plus 0.8 into 1 divided by 2. whatever we will get, that will be the average velocity, that is v bar, or we can say v average over the over that river, right? So here again, if it is greater than 2 meter, the depth is greater than 2 meter, then the v average is what? 0.2 times of the depth of water from the free surface. See, depth of water is suppose this one. If we know that what is this depth, only this formula is valid only when this depth of river is more than 2 meter. Suppose this depth is 3 meter. 3 meter means it is more than 2 meter. So when this is more than 2 meter, then we will apply this formula to measure the average velocity. Is this okay to all of you? Is this clear? Is this clear to you? Now, this is very important. If you will go to any government department in Oman, if you will work in some hydrology department or water resource department, then they may ask that, okay, calculate the velocity, average velocity. What is the average velocity? What is the area of the river? Just they will give you one map, right? They will say that this is the map of the river. See, this is the, so this is river, right? And this is, you calculate what would be the discharge, what is the discharge for this, right? So you have to calculate what would be the area. So first you have to calculate these areas. You will distribute this area into different pieces, right? We cannot say it is simply, it is not rectangle or it is not simply triangular, right? In nature it cannot be happen that we will get the ideal figure. So figure is like this. So you have to calculate this area, then you have to calculate this area, this area, this area, this area, this area. Then you have to calculate the average velocity v bar, or you can say v average. And how you will get v average? There are the methods. If your depth is, so again there is some another different depths, right? This one, this one, this one, this one. So just it is for very small, this formula is for very small, like very small river where the depth is very small. We can say 3 meter or 2 meter is not a much depth. If you will see the river in India or other countries, the depth is almost 10 meter, 12 meter, 15 meter, like this. Now these are the methods to measure the velocity or average velocity. One thing I missed here, you will see that there is a, this is the diagram of velocity profile, right? This, just again you check it once again, I will make it large. See here, this is velocity profile is given. Velocity profile means this is 0.2 times of depth, then 0.6 times depth, 0.8 times. So if I say that, if I will make one diagram like this is one diagram, is just I will say one, this is one vertical axis or this is horizontal axis, right? This is axis x, this is y axis, and here the at bottom velocity is 0. Then at particular some depth, suppose this is depth, so here the velocity is something more. If you will come at this, again the velocity is something more. Likewise you will get one point will come here, there will be the maximum velocity, and again it will reduce and again it will come. So here at different depths, the velocities are given, but generally the velocity, okay, just I will delete it. Now up to here it is clear. So here I think at 0.6 time, at 0.6 times of depth, if we will see that, then I think This is considered as a average velocity at 0.6 times of depth in general. But here are some conditions are given for different types of depth. Now I will come to the next point, next slide. This is just diagram given. Now there is the once we have calculated the velocity, yes. Now the discharge we have to calculate. Discharge, what I told you, discharge is what Q, and Q is equal to V into A, right? So here suppose this river is given. The same thing is here. This is, there are the two methods given, mid section method and mean section method. So what is this mid and mean section method? If you will see that this is the natural, this is the natural diagram of the river, right? It is irregular shape. Now if you will observe that they have taken the breadth, they have divided into pieces, first piece, second piece, third, fourth, and this one is fifth, and they are giving the breadth, and these breadth are almost equal. This breadth is equal for all pieces. So this is piece 1, then piece 2, then piece 3, piece 4, and this is piece 5. B, then the breadth is given B to all. This is B, right? But you will observe that here the depths are different, right? So what they are doing actually, this depth is different, this depth is different, this depth is little different almost, and this one. So they have just taken as the average depth. So here they have taken the average depth di and multiplied by b, they will get that area, right? AI. Once you know that the area, you know, and you know velocity vi or v, so you can calculate the q. This is the midsection method. Now in other method, if you will see, now in this another method, so what they have taken, first they have taken this depth is different than whatever the they have increment is there in the another depth. They have taken the increment in the depth, like see, this depth is di plus, this depth is di plus 1, plus 1 means some more, that may be some more depth. Likewise they will calculate. So he has taken only for one piece. See, this is di and this is di plus 1, or just simply what I say is this is, say, this is becoming one area. This breadth is b, this is di, and this is di plus 1. Means if suppose I say that this area is like this, and this is, say, I say this is 2 meter, this is 3 meter, and the breadth is 1 meter. So how they are getting? See, 2 plus 3, 2 plus 3 divided by 2. 2 plus 3 divided, no, just wait. Now what they are doing? This depth plus this depth, they are adding. So here you can see di plus di plus 1. This is 2, this is 3, for example, I'm telling you. This 2 plus 3, whatever we will get, and this b multiplied by b and divide by 2. Then they are getting the discharge. Actually what they are doing, 2 plus 3 divide by 2 hai. This one is 2 plus 3 divide by 2. They are taking average depth. This, is this clear what I'm saying? This is 2 and this is 3. So 2 plus 3 divide by 2. How much it will, we will get 2.5. right? So that's why this is 2 plus 3 divided by 2 and multiplied by breadth. Multiplied by breadth means we will get this breadth is suppose 1. So 2.5 into 1, then we will get the this area only. For example, if I want to know the adjacent area of this one, so this one, this area, I want to know this area, then what I will do? Again, I will take what is the breadth, what is this depth. This one was 2 meter, right? Suppose this one is 1.9 meter. So what will be this one? 1.9 plus 2 divided by 2. I have taken the average depth multiplied by breadth, multiplied by this breadth. B, that may be say B1 or B2, whatever it is. But generally equal depth is, it is divided into equal depth. So here again what I will get? I will get the area, right? I will say this is A1, this is A2, right? Or you can give a name based on your convenience. Say I will say this is area 1, this I will say area 2, this one is the third one. Likewise, if I will divide it again, so it will be A4 and this one will be A5. Once I know this area, now what is another thing? Another thing is that what is the velocity for this area only? For area A1, what is the velocity? So what is that velocity? Again, they have taken that the velocity for this area is say Vi or V1. So what they will do, A1 into V1, then they will get what? Q1. Similarly, for this area 2, they will say that velocity for this area is A2. What they will get? They will get Q2 because V2 into A2, they will get the Q2. Similarly, for A3, A4, A5, they will get all and they will add Q1 plus Q2 plus Q3. They will get the discharge for the whole. Means they will take the average of discharge and that will be the discharge for the whole river. Is this clear? Is it clear to you? Is it clear to you? All of you? Is it clear? Now, see one example is given. Just we will check this. Estimate the discharge in a stream as shown in figure. Current meter measurements are also given in the table. Current meter means what? Current meter is the instrument. Which instrument? Current meter. Current meter is this instrument. This is our current meter. So through this current meter, this data is collected. What are these? What are those data? See, we will take here. See, this distance is 0 to 3 meter, then 3 to 6, 6 to 9, 9 to 12. Means every distance is how much? Can anyone tell me? Every distance is how much? This distance, breadth is how much? How much is breadth? Every What is the breadth? Can anyone tell me? What is the breadth for this river section? Yes, Meera, Salim, Nadia, 3 meter, correct. Very good. Now, what I'm telling you, somewhere this current meter is installed here. Somewhere current meter is installed in the river, inside the river. As it is, this propeller is moving, then rotation is noted and the time taken by rotation is noted. And this data is appeared or it is collected on the paper here, where you can see that for this width 3 meter and for this section depth, this depth is generally what they are saying, average depth. They are considering this is the average depth for this section is how much? 1.4, and breadth is 3. Just wait. And the data collected for this first section, I say, is number of revolution is 12. 12 times this propeller is rotated, and time taken for rotation is 50 seconds. Now you know this all data, and we have the formula here. Actually, this formula is directly given, and again I will come back, so I will show you some that formula, basic formula for the current meter. See here, just you see this formula, right? What is this? Velocity is equal to A plus B into N. N is what? Number of rotation, right? Number of rotation here already given. No need to write to me. See here, for the, see here, this V is equal to A plus B into N. N is what? N is the revolution per second, right? This one. What is B and what is A? B is what? Equipment calibration constant. That constant is given. Generally, for the different instruments, some calibration constant is given. If we know that, and we know N, and what is A? A is the starting velocity to overcome the mechanical friction. Means is some at some in the starting we assume something, some velocity, that will be A. So if this formula is modified, if this formula will be modified, then modified means this formula, some constants are derived for this formula. So this formula becomes, this formula becomes this one. This formula becomes V is equal to 2.3 into N plus 0.05. Means after a lot of trial and error, trial and error, trial and error, continuous trial and error, we get this formula, right? So we know that this formula, what we do then? So here just you check this. Number of revolution is, say, suppose 12, right? And this 0.05 is the constant given, that is already derived. So when you will put this value 2.3 into what is the number of revolution, means this N value 2.3 into how much I will put 12, because this is for first reading. For first reading 12, 2.3 into 12 plus 0.05, right? If I will do this, then I will get the velocity for this section, right? Similarly, we can calculate, for other areas also. So likewise, we can calculate, if we have the values, we can calculate the velocity at different uh, sections. So we will get the some velocity. Once we know the velocity, right, we have to know what is the area, this area. We know B, right? See here, if we know B, we know the depth, so we can find out the area. Can you tell me for area for this? What would be the area? See, this is 3 meter, and this depth is given here, see, 1.4. So we can find out the area. 4.2, it will be 4.2, area will be 4.2 meter square. Once we know the area, we know the velocity, simply we will do what? Q is equal to V into A, and we will calculate the discharge over this area. Similarly for another area, and likewise we will calculate for all, we will calculate the discharge for all. And once we will add for all discharge, like how many areas are here, just I will count: 1 2 3 4 5 6 7. If I will add q1 plus q2 plus q3 plus q4 plus q5 plus q6 plus q7, then I will get the total discharge through this river. Is it okay? Is it okay to you? Is it okay? Now I will come to the another. See, some examples are given. Just you take your mobile or calculator. Just you check is. See, the distance from left edge means this one. From left edge means 0, right? The distance from left edge is, this is 0 to 3, then 0 to 6, then 0 to 9, right? 0 to 12, 15, 18, and 21. This distance is given. So distance is 3 meter from 0 to that is 3 meter. The depth is 1.4 meter. And area, what I told you, what would be the area? Just multiply by the depth into the breadth, you will get the already area is given for this actually. See, for this section actually, depth is given. That depth is what? 1.4 meter. But only breadth is given, right? This is 3 meter. So the same thing is here. Breadth is given 3 meter from 0 left, and the depth for that area is 1.4. Current revolution, this n is value is 12, and time taken is 50 second rpm. So you will put the value, then you will get the velocity. Once you know velocity, you have to multiply by the area. For example, you will multiply this. See, this is the value of v, and this is the your area, right? If you will multiply 2.1 into 0.602, you will get what? This value 1.24642. You can check also. Now for the same section, suppose again one reading is taken, that was 38 and 38 revolution, and this was in 52 seconds. This is revolution per second, and it is number of second. This is two different things. Okay, so be clear with this. So for example, what I told you, if you know everything for all area, just when you will add this, you will get the total discharge here. So you know this one will be for first area, second, three, fourth, fifth, sixth, seven, and we will count here. We will also count here. 1 2 3 4 5 6 7. 7 areas are here. For 7 areas, seven values of q are there. when we will add this value, we will get the total discharge from this river. Is it okay? So once
دكتور
if fine, yes,
دكتور I
yes,
want to know column number 3. Okay, we have area. Yes, from where he give this data directly will give to me or should be substitute?
this one,
Yes, column number 3, doctor.
this one.
Yeah,
This is area given. They have already, they know already the area of this one.
but it's not same. Check, doctor. For example, take from left 0 up to 3. Okay.
This is right.
Okay.
This is the
Yeah.
area.
Okay. You
This
are
is the area,
before
and
you are
that
take
area is
3 multiply 1.4. It will become 4.2. Yeah.
okay. I will check.
Yeah. Because it's not same data for area.
Just we will check
Okay,
how
doctor.
it is
Thank you
coming.
for you. Okay.
3
Because I'm
into
think should be substitute another rule for di
0
plus
plus
di1.
1.4 divided by 2 multiplied by 3. See here, what is this actually?
Yeah.
See here, what they are taking. See here, they are taking this depth is 1.4 meter. Is it okay?
Yes, doctor.
And another end they are taking considering it as a 0. So 0 plus 1.4 divided by 2. They are taking the average depth. So how much it will be?
0.7.
0.7 multiplied by this breadth is 3.
Now is correct.
So it will, how it will become? It will become
2.1.
2.1.
1.
Is it okay?
Now is correct, doctor.
Now again we will check another for another portion. See, another portion is saying
For example, take 3. Come back another table, doctor. First one.
uh, 1.4 plus 3.3 divided by 2. 2.35
2.35.
multiplied by 3 because again this is 3.
Yes, doctor. Now it will
Now,
come.
now we will check how much it is
It
coming.
will be correct, doctor. 7.05.
Now, so it is okay. So what
Yes.
they are doing,
Now okay.
area multiplied by the velocity. Velocity is already given. Suppose they have the data, velocity data. So when you will multiply velocity with the area, you will get the discharge. Is it okay?
Yes, doctor. Now okay.
So if you have any doubt within this, you can ask me also. Anyone, other students, if you have any doubt. Likewise, you can calculate for this one also. 3.3 plus 5, how much? 3.3 plus 5 divided by 2, 4.14. Multiplied by 3, 12.45. Is it okay?
Yes, doctor. Now correct.
Now, so likewise, we will calculate this discharge. So in the next lecture, we will continue after this, another example, right? Is it okay?
Inshallah. Okay, doctor. But please, doctor, send the lecture slide. Okay.
Yeah, inshallah, I will send this.
Thank you for you, doctor. Thank you.
Okay. So if you have any doubt, you can ask. And in the coming week, inshallah, we will have a quiz too. And at the end of this holiday means in the weekend, I will send you the assignment one. So be ready for the next week.
دكتور توصيف.
Yes.
Doctor, now we should be take 2 quizzes. One quiz is 20 marks.
That will be converted half.
Into
that will be converted into 10
half.
marks. Yes.
Okay, so that means both the quizzes it will be 20 marks. Okay.
Yeah.
Assignment.
We will
How
have
many
a
assignments?
2 assignments, 3 quizzes.
Because the time is only 1 month we have.
No. We have up to January,
More 2 weeks.
because this is the 9th week.
Yes.
And we have total 14 weeks. Now from here you can count 5 weeks. Not 5,
Inshallah,
6
Doctor.
weeks.
Because better to get 2 or 3 quizzes, also 2 assignments.
Yeah, that is good because we
Okay.
still we have almost 10th, 11th, 12th, 13 and 14 means 5 weeks we have. So we will go very
Alhamdulillah.
slowly
Thank you.
and we will do very easily.
Thank you for your work, Doctor. Thank you for you. Thank you.
Yeah, right. So please be ready for the coming week quiz, and inshallah in the weekend I will give the assignment one. So here I stop.